Hello, first year students. I hope you're all doing well despite the high heat index. Today, let us discuss about Lesson 6, the classifications of matter. In this lesson, we will be able to distinguish and describe the classifications of matter, including elements, mixtures, and compounds. Then, we will also distinguish between homogeneous and heterogeneous mixtures. Later on, we will have hands-on activities to demonstrate at least three simple homogeneous mixtures and three simple heterogeneous mixtures. Now, without further ado, let us start. So look at this diagram. This is an example of classifications of matter. So let's think of it like matter is a big family, okay? Since this is a big family, at the top, we have the grandparent of all materials, which is matter. And matter has two children, the pure substance and mixture. Under the pure substances, there are two more categories, which is the element and compound. On the other side of this family tree is mixture. And mixture have two categories or two types, namely homogeneous mixture and heterogeneous mixture. We will delve further later on these terms. Now, what are pure substances? Pure substances are a sample of matter that has definite chemical and physical properties. In this example, we have four types of pure substances that we're going to talk about: elements, atoms, molecules, and compounds. Elements, they are like solo artists of the matter world. So they are represented on the periodic table, and each element is made up of one type of atom. Think of oxygen, for example. It's an element because it is only made up of oxygen atoms. Atoms, on the other hand, are like the smallest indivisible units of matter. And I know you're very familiar with this. Atoms are the basic or the smallest unit of matter. So, they're the tiny particles that make up the elements. Each atom has a nucleus with protons and electrons surrounding it. Next, we have molecules, and these are like a group of atoms joined together. They can be the same type of atom like oxygen gas. Oxygen gas contains two oxygen atoms. And we have water, okay? Water molecule. So the water molecule contains two hydrogen atoms and one oxygen atoms. Lastly, we have compounds. We could say that compounds are like a team of different elements that have chemically bonded together, or they are chemically bonded together. So, water is actually a great example of compound because it is made up of two hydrogen atoms and one oxygen atom that have chemical bonds, or they are chemically bonded together. Moving on, pure substances is also defined as a substance that has a fixed chemical composition throughout. It does not have to be of single chemical element or compound. So we could also classify homogeneous mixture a pure substance, but we just need to remember that a mixture of various chemical elements or compounds also qualifies as a pure substance as long as the mixture is homogeneous. And lastly, we need to remember that pure substances cannot be further broken down or purified by physical or chemical means. An example of pure substances includes gold metal, copper wire, sugar, salt, hydrogen gas, and diamond. Now we have elements. Elements are pure substances that cannot be separated into simpler substance by physical or chemical means. We could say that elements are like the fundamental substances that make up everything around us. They are pure substances that can't be broken down into anything simpler by physical or chemical means. So it's like the universe's building blocks, each with its unique properties and characteristics. So look at the comparison between elements and compounds. On the one hand, we have elements. Elements are like the solo artists of the matter world. They are pure substances that only contain one kind of atom. For example, helium or He. It's an element because it is only made up of only helium atoms. On the other hand, we have compounds. Compounds are like a band of different elements that have come together to create something new. So they contain two or more kinds of atom. An example of that is water. Alright, compounds are pure substances that are composed of two or more different elements joined by chemical bonds. We could say that they are like a team where each player brings something unique to the table. They are always made up of elements in a specific ratio that doesn't change. So every compound has its own chemical formula, kind of like an identity card that tells us exactly what it's made of and what proportions. And they can only be separated by chemical means and they cannot be separated by physical means. We have the term binary compounds, and this refers to two different elements. So, a binary compound consists of two different elements. This includes water, because water contains two hydrogen atoms and one oxygen atoms. Then we have salt. Salt contains two different elements such as Na and Cl. Next, we also have silicon dioxide. It contains one atom of silicon and two atoms of oxygen. Hydrochloric acid. This consists of one hydrogen atom and one chlorine atoms. Then we have nitrous oxide, a two nitrogen and one oxygen atom. Now we have covalent compounds, such as compounds like ammonia, hydrogen, and water. They are called covalent compounds because they are joined with covalent bonds. When you say covalent bonds, this has something to do with sharing of electrons. Okay? So, for example, in the ammonia, we have NH3. So, N is covalently bonded to three hydrogen atoms. Then we have H2, or this one hydrogen atom is covalently bonded to another hydrogen atom. Next, we have water. Oxygen is covalently bonded to two atoms of hydrogen. Next, we have ionic compounds. These are the compounds that are formed because they are joined together by ionic bonds. For example, table salt. Okay, table salt, Na and Cl, they are joined by ionic bonds. And we have baking soda, drain cleaner, lye drain cleaner. Then we also have Epsom salt and bleach. All of these are ionic compounds because they are joined by ionic bonds. Next, we have the carbon compounds. Okay? Carbon compounds are like the two sides of the coin. On the one side, we have organic compounds. These come from living things and include stuff like sugar, protein, and starch. It's like the ingredients that make up life. On the flip side, we have inorganic compounds. These aren't derived from living things. Examples of these are carbon dioxide, sodium carbonate, and chalk. It's like the stuff that makes up the non living parts of our world. Next, we have the organic versus inorganic compounds. On the one side, we have organic compounds, and these contain carbon, usually bonded to hydrogen. An example include DNA, sugar, methane, and ethanol. They are pretty much the stuff that's fundamental to life as we know it. On the other side, we have the inorganic compounds, and these usually don't contain carbon. Think of table salt or hydrochloric acid. They're not based on carbon but are still super important in chemistry. There are other some exceptions like carbon dioxide and some carbonates, cyanides, and carbides, which are considered inorganic. Now we have further classifications of the two types of compounds. So organic compounds, they are based on carbon elements or presence of carbon, while the inorganic, they are not based on the presence of carbons. But please remember there are exceptions to the rules like carbon dioxide, carbonates, cyanides, and carbides. They are considered inorganic compounds despite containing the element carbon. Okay, they are considered inorganic because they do not come from living things. Only they contain the carbon atom. Okay, so organic compounds are non-electrolytes while inorganic compounds are electrolytes. Like they could be an acid, they could be bases, or they could be salts. Organic compounds are usually bonded through covalent bonding, while on the other hand, inorganic compounds they are joined together by ionic bondings. Organic compounds have low boiling and melting point, while inorganic compounds have high boiling and melting point. Organic compounds are soluble in nonpolar solvents, and inorganic compounds are soluble in polar solvents such as water. Organic compounds have a complex structure, while inorganic compounds have simple structures. Organic compounds are made up of millions of compounds, while inorganic compounds are made up of thousands of compounds. Alright, so we have further examples of organic compounds such as paper, nail polish, candle, fabric, soap, and gasoline. So paper is made from cellulose. Cellulose is actually an organic compound that comes from the plant cell walls. It's what gives paper its strength and flexibility. Next is the nail polish. It actually contains nitrocellulose and butyl acetate. This is the reason why it will dry quickly and give that shiny finish that we all love. And we also have candles. Candles are actually made from wax or tallow, which are organic compounds that can be burned to produce light. Next, we have fabric. Fabric can be made from a variety of organic compounds like cellulose, nylon, and rayon. These materials give fabrics their softness, durability, and flexibility. Then we have soap. Soap is actually a fatty acid salt. Okay, so soap can help clean our skin, right? So it clean by allowing water to mix with oil and dirt so they can be rinsed away. And then we also have the last one, gasoline. It is a mixture of hydrocarbons, and these are also considered organic compounds that can be burned to power oxygens. So we are done with pure substances. Let us proceed to mixtures. And mixtures again have two categories, the heterogeneous mixture and the homogeneous mixtures. The mixtures are actually combinations of two or more pure substances that are not chemically combined. That's why in the previous discussion, I have mentioned that mixtures do not contain chemical bonds. Okay, so mixtures are actually substances held together by physical forces, but not chemical bonds. Therefore, in a mixture, no chemical change takes place. Each item retains its properties in the mixture, and they can be separated physically. Alright, so speaking of the two types of mixture, We have the heterogeneous, which means different, and homogeneous, which means the same. So in a heterogeneous mixture, you can see the different parts or the faces of the mixture easily. On the other hand, homogeneous, you cannot see the different parts or the faces of the mixture because the molecules are evenly distributed. So look at this one. In the homogeneous mixture, the particles or the molecules are evenly distributed or they have a uniform distribution, while in a heterogeneous mixture, they are not evenly distributed, and therefore we could see the different parts. While homogeneous, we cannot see the different parts of the mixture. Furthermore, a mixture of substances blended so thoroughly that we cannot see individual substances is called homogeneous mixture. Homo means the same throughout. Homogeneous mixtures are also called solutions. So, in a homogeneous mixture, it has a uniform appearance, which appears to look the same throughout, and uniform composition, are made up of the same types of particles. Okay? And all the substances that make up the mixture are evenly distributed. For example, homogeneous mixtures can be solid, liquid, gas, or plasma mixture. Now, look at this image. We have further examples of homogeneous mixtures. So, homogeneous mixtures are like a perfectly blended smoothie. They are a mixture of substances blended so thoroughly that you cannot see individual substances. So, the term homo, just like I said before, means the same. And that's exactly what's happening here. Everything is Everything is evenly distributed and looks the same throughout. Examples, we have coffee, wine, air, brass, steel, natural gas, vinegar, and blood. Then we also have solutions. Solutions are also homogeneous mixture of two or more substances in a single physical state. There are different types of solutions based on their physical states. So we have solid, liquid, and gas. But before I forget, there are the main parts of a solution, and we call that solute and solvent. Okay, so solutions could also be classified as miscible or immiscible. When you say miscible liquids, these are liquids that dissolve freely in one another in any proportion. While immiscible liquids, so these are liquids that are not soluble in each other. So solutions can also be saturated, unsaturated, or supersaturated based on the amount of solute in the solvent. Then they could also be dilute or concentrated based on the proportion of solute in the solution. And lastly, solutions can also be electrolytes or a non-electrolyte. So later on, we will discuss this. So let us talk about this first, solubility. Solubility is actually a fascinating concept in chemistry. It's all about how much of a solute can dissolve in a solvent. So imagine you're making a cup of hot chocolate. The chocolate powder is your solute, and the milk or water is your solvent. Now, if you keep adding chocolate powder and it all dissolves, you have an unsaturated solution. Okay? But what happens when no matter how much more chocolate you add, it just won't dissolve anymore? Well, you will have a saturated solution. Now, what if you were able to get more chocolate to dissolve in that already saturated hot chocolate? Maybe by heating it up a bit more. Well, then you will have a super saturated solution. Okay? So look at their differences. In the unsaturated solution, more solute dissolves. In the saturated solution, no more solute dissolves. Supersaturated solution, it will become unstable and crystals will start to form. Now, in terms of concentration, unsaturated solution is not so concentrated compared to saturated solution, because saturated solution is more concentrated than unsaturated solution. Supersaturated solution is more concentrated than saturated solution. So next we have the dilute and concentrated solutions. A dilute solution has a small amount of solute in a large amount of solvent, while a concentrated solution has a large amount of solute in a small amount of solvent. So in this example, we have here the small balls or the small circles are the solutes, while the blue liquid is water. That is our solvent. So in a diluted solution, we could only see a small amount of solute. In the concentrated solution, we could see that it has a large amount of solute in a small amount of solvent. Say for example, this one. Okay, our solute is sugar, our solvent is water. Now, if we are going to mix this, sugar will be dissolved in water. And thus, this will be our solution. Okay, sugar is dissolved in water. Now, we have the difference between electrolyte and non-electrolyte. So by definition, electrolytes are substances that produce ions when dissolved in a solvent. And we know that ions are atoms with charged particles, so it could be a cation or an ion. Then we have non-electrolytes. So by definition, these are substances that cannot produce ions when dissolved in a solvent. Now, in terms of production of ions, electrolytes could dissociate into ions. Like I said, it could dissociate or it could produce cations or anions. But in the case of non-electrolytes, they cannot dissociate into ions. Then we have polarity. Electrolytes have polar compounds, while non-electrolytes have non-polar compounds. Then in terms of electrical conductivity, electrolytes can conduct electricity when dissolved in a solvent. On the other hand, non-electrolytes cannot conduct electricity. So for example, electrolytes can be NaCl, calcium phosphate, and many other ionic compounds. And then examples of non-electrolytes, we have sucrose, glucose, ethane, and etc. Now let's proceed to heterogeneous mixtures. These are mixtures that does not blend smoothly throughout, in which the individual substances remain distinct. This means that we are able to identify the different parts or the different substances in the solution or in the mixture. Hetero means different. So this also means that the composition is not in uniform like the homogeneous. In this kind of mixture, we can distinguish all the components. So more than one phase of matter may be visible in this type of mixture. So an example of heterogeneous mixture, so in the case of solid, we have a salad. So look at the picture of the salad. Can we distinguish the different parts that make up the salad? Yes, we can see a cucumber, lettuce, carrots, and so on. For as long as we can distinguish the parts, so that is an example of heterogeneous mixtures. Now in liquid form, we have ice cubes in a drink. So can you see the soft drink? Can you see the ice cube? Yes, because this is a heterogeneous mixture. Now we have smog. Smog is actually a mixture of smoke and fog. Another example of heterogeneous mixtures includes chocolate chip cookies. So we could distinguish the cookie from the chocolate chips. And we also have pizza. Okay, we can see the cheese, the dough, the pepperoni. What's that? Is that, I think that is basil. So yes, so we can still distinguish the parts. Then we have soda with ice, sandwich, and tossed salad. Now let's proceed to the ways to separate mixtures. The first method of separating mixtures is distillation. Distillation is the separation of constituents of a liquid mixture by vaporization and then again condensing the vapor into liquid. It involves a change of state from liquid to vapor and again to liquid. Distillation also uses boiling point. Now, to further explain this, I want you to look at this distillation setup. Okay, so distillation actually involves two stages, the evaporation and condensation. The mixture is heated to force components which have different boiling points into the gas phase. So the vaporized components then pass through a condenser where they are cooled and returned to their liquid state. So as depicted in the distillation apparatus, you can see the distilling flask which contains the liquid mixture to be purified. It is heated by a burner, causing the liquid to vaporize. Then the vapor rise and pass through a thermometer that monitors the temperature to ensure it remains within desired levels. Then the vapors enter the condenser where they are cooled back into liquid form. This is facilitated by cold water circulating within the condenser, entering through the cold water in and exiting through water out. The purified liquid, now referred to as distillate, collects in the receiving flask. So this is actually essential. Okay, it's essential that each component is precisely calibrated and monitored to ensure the purity of the collected distillates, separating it from impurities effectively, which is the magnetic separation. This is the process of separating components of mixtures by using magnets to attract magnetic materials. Magnetic separation uses magnets, and a magnet is a material or object that produces a magnetic field. This magnetic field is invisible but is responsible for the most notable property of a magnet. All magnets have north and south poles. Opposite poles are attracted to each other, while the same poles repel each other. So look at this magnetic separation. Initially, the two substances are combined, right? So in the image provided, we can observe this process being applied to a mixture of sand and iron fillings. So the two substances are combined. So by simply hovering a magnet over the surface of the mixture, the iron fillings will be attracted to the magnetic field. Okay, so because of this, the iron fillings will be effectively separated from the sand. And this leaves us with distinct identities, the iron fillings attached to the magnet and the sand remaining in its original place. And then we have the centrifugation. Centrifugation is a fundamental process in the field of science, particularly in laboratories where the separation of substances within a mixture is crucial. It involves spinning a mixture of high speed, utilizing centrifugal force to separate its components based on their densities. The equipment central to this process is called the centrifuge. It is actually a specialized machine designed to spin containers of liquid at high speeds. So, as the centrifuge spins, substances within the mixture are subjected to centrifugal force, which causes them to separate according to their respective densities. the most dense components migrate towards the bottom, while less dense substances rise to the top. So this is efficient and effective method because it will ensure that each component can be isolated and analyzed individually. So this is the centrifuge machine, okay? A specialized machine to spin containers of liquid at high speeds. Now let's talk about the centrifugation of blood. In the context of blood analysis, a blood sample is placed in a tube and then spun at high speeds in the centrifuge. This separates the blood into its various components, making it easier to analyze specific elements within the sample. So, as the centrifuge spins, the denser components of the blood, such as the red blood cells, move to the bottom of the tube. The less dense components, such as the plasma, remains at the top. So this separation allows for more precise analysis of the different components of the blood. Okay, so look at the image carefully. The red blood cells is suspended at the bottom, while the white blood cells and the platelets can also be seen. So it is in between the plasma and the red blood cells. So what is the less dense? Okay, it is plasma because it remains at the top. Now we have filtration. Filtration is actually the process of separating a liquid and an insoluble solid. For example, separating sand and water. Filtration uses a material which allows the liquid to pass through but not the solid. An example of that is the use of filter paper. So look at this setup. In the filtration setup, a mixture of solid and liquid is poured into a funnel that contains filter paper. This is actually aided by a steering rod to reduce spillings or to avoid spillings. Okay? So the funnel is supported by a ring stand, ensuring it's held securely above the collection vessel. As the mixture is poured, the liquid, now referred to as the filtrate, passes through the filter paper and collects in the vessel below or the beaker. The solid particles, being too large to pass through the filter paper, are trapped, effectively separating them from the liquid. And then we also have evaporation. Evaporation is actually the process in which a liquid changes into gaseous form on heating, allowing the liquid to evaporate, leaving the soluble solid behind. An example of that is water and salt. So it is actually a method of separating a solid from a solution. So in order for you to understand it, I want you to look at this evaporation setup. So we have here a mixture of salt and water. So it is placed in an evaporating dish. So the dish is heated by the Bunsen burner, causing the water to evaporate. And so as the water evaporates, the salt remains in the dish. And we can see that salt, which is our solid, is separated from the solution, which is water. I mean. Okay, so we have here a comparison between mixtures and compounds. So in terms of composition, mixture has a variable composition. We can only vary the amount of each substance in a mixture. So compound has a definite composition, meaning you cannot vary the amount of each element in a composition. Now, mixture, they are actually not chemically joined together. On the other hand, compounds are chemically joined together. In terms of properties, mixture, in each substance of the mixture it has its own properties, while compounds has properties different from the elements it contains. So in terms of separation, so in a mixture, each substance is easily separated from the mixture, while in a compound, it can only be separated into elements using chemical reactions. So an example of mixture, we have air, seawater, and rocks. And we have here compound examples: water, carbon dioxide, magnesium oxide, and sodium chloride. Alright, so that would be all for lesson 6 with classifications of matter. And I hope you have listened and really watched the discussion as we are going to have our exam on Tuesday. Okay, please study. The coverage of the exam will comprise of lesson 5 and lesson 6. So good luck, first year students, and that would be all for today. Goodbye.